right, so we're back. Let's see if everybody else gets a chance to log on. Nice. Waiting for everybody to come back. So sending out some more messages, letting everybody know we're back. Okay, hello, Ruth. Should be getting a few more people joining us here. And we're going to pick up right where we left off. Someone else just joined us. All right, Danny. And if you guys would like the conference call, let me know. I will call right back. I think everybody now had a chance to work it out. Hello. And please let me know in the comment section or the live chat if you would like to use the conference call, because we're going to get knee deep into this. And I know, again, probably sound like a broken record. So, I haven't called in yet. Let me call in now. All right. So Danny, at least she already has the answer. Very nice. So I'm on the conference call now. If you try to join and it says you have an invalid pin, anything like that, let me know. I will reach out to you so that you can join, because we're going to talk about a couple of ways to solve this. Hello, who just joined us? What's that? All right. I'm actually going to give Danny a call. I know she wanted to join as well. Hello? Hey. That's all right. We got you now. All right. So we got Danny Ildy. Okay. And then Roof will be joining us in a moment. And we got Lindley in here. Again, Lindley, if you'd like me to reach out to you to have you join the conference call so that you can ask questions, we can do that. If it's easier for you to text the questions, that's fine. Okay. So last when we left off, we knew that y equaled 12. The last time that we left off. So we erase this. So what are we going to do now? We know that y equals 12.
So we have to plug in the y. So it's going to be x equals 2 times 12 minus 15.
Okay, so we want to plug the y in here. So you said, so this would be then negative 5x plus 4 times 12 equals 3. Is that correct?
No, we got to do the minus 15 in there too.
What's that?
I solved the problem separately. I did the x formula.
Yeah, there's several ways to do it. Okay, so that's one way. All right, so you said you felt more comfortable saying, okay, x equals 2 times 12 minus 15. So why did you choose to do that as opposed to plugging it into this equation?
Just simpler. The less numbers and confusion you have.
Good, yeah. So good. So we would call that a friendly number or a friendly equation. So there's actually a mathematical theory behind that. So even if you had to explain that, you would say this is an easier equation to solve, and that's why I picked it. Okay. So what would I do from here? What's my next step?
2 times 12 is 24. Minus 15 is 9.
So this would be 2 times 12, which is 24, minus 15, x equals 9. Was that Ildy?
Yeah.
Smoking it.
So don't give me credit.
No. Hey, you know what? Studies have shown that you guys learn more from each other than you do from the teacher. In fact, in schools, we use something called Kagan structures where we force the kids to talk to each other. I failed students for not talking to each other. So if I put up a problem and students are not discussing like how to solve it, different methods, they would fail. So it is your credit. It is on you because you took the initiative to talk to someone else and get that feedback. Does this make sense to you now?
Okay, cool.
Yeah. Does it make sense?
This way, I mean, it definitely was easier to figure out X this way, the way she did it, than going back to the first equation, because that looks way more confusing.
Which means you're probably more likely to make a mistake, so on and so forth. Yeah. Any questions on that so far?
Now that we know what X and Y equal, it's easier to plug it into the original formula and know that it does equal 3.
There you go. Questions on that so far?
No, but I still had, like, the X after Jenny explained it, because we were on the phone in the break and she was explaining it to me. The X was, the way she explained it and the way she solved it was really easy. But if I had to go back and do Y again, I would totally get confused because it's such a long equation and such a long problem to do. I wouldn't know where to put the numbers. Like I don't know.
So here's what I would recommend. So anytime you're looking at these systems of equations, because these will come up on the test quite frequently, I would automatically look at whichever equation is going to be easier, and I would automatically plug it into there. If both equations are longer and have like more variables and operations, then I'll always recommend going from that top to bottom. Take everything piece by piece. It's like the old saying, the easiest way to eat an elephant is one bite at a time. So if I were to look at this, I'm like, man, that's intimidating. There's a lot of variables and operations, but that's why I go literally line by line. So I'm never looking at the whole thing. I'm really looking at pieces. Like the first piece is to get the variables by itself. Second piece is to get all the whole numbers on the opposite side on the equal sign. And if I work through it that way, it's easier to follow. It's not as intimidating because I'm looking at it.
To me, organizing the numbers are like really confusing. Like I look at it, and even though I watched you 20 times already, and the 21st time you're gonna say solve it by yourself, I don't know where to start. I just feel so I have a block.
Always start with these letters. Always start with the variables first. Always try to get the variables by themselves. And it's okay to do that. I think I'm a very good teacher. I will go over something, Ildi, no joke. I've counted 150 times. There's no shame in that. Especially like,
oh, you are a very good teacher.
Oh yeah, but
I agree with that.
Yeah, like if I don't understand, oh yeah, no worries. And I'm just saying that like even if it takes several times to do it, it's okay. Because I think there's a perception out there that like when a teacher does something that it's easy, and if you're not getting it, then you're dumb. And that's not true. In fact, I know more teachers that will only stick to what they can do well, as opposed to doing the same things, discussing with somebody else, trying the problem several times. So I can tell you that I don't think I'm comfortable with this because I'll do it 100 times. Like I will break the problem before the problem breaks me. And that's like what I always suggest to my students. Look at, if it's just a mental block where it looks intimidating, then I would try to attack that first, right? Okay, hey, it's not all of this. I'm only looking at this right now, right? Or I'm only looking at the 3.
Remember how we plugged in the -2 and we got a different answer because we were working with -2? That's the other thing you can do. Keep trying it and plugging those numbers in until the problem actually makes sense.
Yep, and that's called using algebraic thinking. And that's why if you are able to do that, you'll be in good shape, because on the test, you're going to get a lot of questions where it's multiple choice. So right out the gate, you can start plugging in those numbers to see if it'll make the equation true. And if it doesn't, then you eliminate it. So I think that you're doing very well, Ildi, and I know that as we practice, it'll start coming through. But definitely don't think that when you look at this, it's intimidating and that you're the only person, and that if you're not getting it as fast as you would like to, that it's a sign that you're behind or anything like that, because it's not. Like I will practice this and I review it over and over, and it's one of the best things you can do is that repetition, and then looking at where you break down. So if the equation looks intimidating, just remember we're working it piece by piece, and I always stick to the same
Okay.
method. So let's try another one.
Okay. Thank you.
You're very welcome. So let's look at 4x plus 3y equals -2. Y equals x minus 1. Yeah, you could help. Yeah, the more the merrier.
So do we want to talk Y first?
I would say to do that because you know what y equals, and that's why they give you that. So I would substitute what y equals into the first equation.
how to start it. I'm looking at it and I don't even
Okay.
know how to
So
start
what's
it.
the first thing we do when we know what one of the variables equals? What's the first thing we do?
I don't know. Okay, so you see where the Y is, Ildi?
Oh, hold on. So think about it. Do we know what any of these variables equal?
Well, Y equals.
So what should we do next? We know what y equals, so what should we do next? It's okay. Think about it, right? Like if we know what y equals, then what do we want to do next? We already know what one of the variables is, right? We know that.
We're going to find out what X equals.
Good. So that means we're going to take and do what with it? You're exactly right. So what are we going to do with what we know y equals?
I didn't see what were you pointing at? What do we want to do?
Okay, so we know what y equals, correct? Y is all of this. So what do we have to do?
I don't know.
Well, if we know what y equals, then we have to take all of this and remember, we're trying to get
add it to the.
There you go. See, that was all you. That was no help from anybody else. That was all you. Good. So let's rewrite this now with this into the equation. Y equals x minus 1. So we're going to have negative 4x plus 3. And what do we say y equals?
X minus 1.
So this is going to be times x minus 1 equals negative 2. Is that right?
Okay.
Now remember,
I'm making like a step-by-step notes for myself right now.
There you go. Everyone will do well on this. I can guarantee it. Guarantee it. And I have the numbers to back it up. Everyone will master this.
Okay.
All right. So what's the next step? I got rid of that y. So what do I want to do now?
Are we multiplying the 3 by the x and the 1 in the parentheses?
See, you're killing it. Oh, love it. All right. So now, and here's where I always recommend. I always like to rewrite it because that can get confusing. So I don't try to do any of this in my head. So I'm just going to continue to rewrite it. Negative 4x plus, so 3 times x is what?
3x.
3 times negative 1.
And negative 1 is negative 3.
Negative 3. And what else do I put?
Equals negative 2.
Correct. Now what?
Okay, writing it down. Okay, hold on. 4. Because I'm literally trying. I'm literally putting words with my steps.
Love it. Love it.
Just looking at the numbers is not helping me. I don't know what I'm doing.
And that's okay. What you're doing is called metacognition. You're thinking about your thinking. You're going with what is going to make the most sense to you. And that's the whole purpose of this.
Okay. Okay. All right. Right now.
Okay. We'll see what that means, Ruth. Go ahead.
So right now, step 3 is going to be eliminating numbers.
Yep.
And we're going to eliminate the negative 3.
Okay.
So we're going to add 3 to both sides.
Killing it. Now I'm going to rewrite the whole thing now.
So that's going to be negative 4x plus 3x equals positive 1. Oh, no. Negative 5.
Well, if you're negative $2 in the bank and I gave you 3.
Yeah, positive 1.
Mm-hmm. Now what?
Now we're going to solve the x's. So negative 4x plus 3x is going to be negative 1x. Then I'm going to divide. Oh.
Yeah, you're going to divide.
Oh, equals 1. Equals
Yep.
1. Equals 1.
But you were right. You're going to divide.
And I'm going to divide. Then I'm going to divide both sides by 1, negative 1, actually.
So x equals what?
And it's x equals negative 1. Okay?
That was all you, Ildi. That was all you. And that's it.
But I got the reassurance that that's correct or not.
No, I didn't give you any reassurance. I literally wrote down everything that you said. I did not give you any reassurance on anything. I literally wrote down everything you said. That was all you. All you. 100%.
Okay. Thank you.
You're welcome. Okay, so now that we know what x equals, what should we do?
Now we need to find out what. We need to plug it back in.
Yeah. Now, out of those two, which one would it be the best to plug into? You see two equations. We know what x equals. So which one should we plug it into? Let's go with the easiest one.
Y.
Okay.
What? No.
So let's see.
X,
So y equals, we know what x is. What is x?
Negative 1.
And then minus 1.
Negative 1 minus 1 is negative 2, or is it positive 2?
I don't know. You tell me. Which one is it?
Negative 1 minus 1. It's negative 2.
That problem was done 100% by you. And those are your answers. You can even plug them back into the equation. Killing it. Yeah, and Danny says, stop doubting yourself. You're brilliant. I agree. I agree. Killing it. There you go.
I'm still so unsure.
No. Don't doubt yourself. You killed it. That was you. I didn't do anything. That was literally you. 100%. You got this.
Thank you.
You're very welcome. You got this. And the best part, too, is that there's another method we can use. So that's going to give you even more power when we talk about other ways to solve it, because now that'll be another method and you can look at which method you're most comfortable with. You want to move on to the new method, or you want to do another problem like this using the elimination method? I'm sorry, the substitution method. We're going to work on elimination.
We can do one more like this, I guess.
Okay. So we're going to do one more using substitution.
I'm down to do one more.
All right. So let's look at one more. So this is going to be negative 10x plus 3y equals 5. X equals y minus 4. That's a school district. They can wait. Hang up on that. And whenever you guys are ready to work it out, let me know.
I got stuck. Same here. I'm not getting an even number.
Not getting an even number?
No. I got stuck.
Okay, so let's work this out together. So what's the very first thing we're going to start off with?
We're going to rewrite the problem.
All right. So it's going to be negative 10. And what are we plugging in for x? Y minus 4?
4.
Yeah.
Plus 3y.
Uh-huh.
Plus 5.
So what should I do from there?
So negative 10. We're going to multiply 10 with y and 10 with negative 4. Negative 10 with y, negative 10.
So let's rewrite that. What's that going to give us?
Negative 10 times y is negative 10 times 10y.
Yeah, so negative 10 times y gives us what? See, and notice I always do the arrows just to remind myself. So negative 10 times y is what?
This is where I got stuck. Is it negative 10y? I wasn't
Correct.
sure about
Negative
that.
10y, because you can't combine it any more than that. We can't combine it any more than that. So that's all we can do. So we got that. Now what do we do?
Negative 10 times negative 4.
Which would give you what?
Yes. Positive 40.
There we go. I'm going to keep writing everything else.
Plus 3y equals 5.
Now what?
So now we got to subtract 40 from 40 and 5 minus 40.
So now we're left with negative 10y plus 3y equals, and what's 5 minus 40?
Negative 35.
So what do we do now?
So negative 10y plus 3y is going to be negative 7y. So now we divide. The 7y equals negative 35. The dividing it, y equals 5.
Good. Now what?
Now we go back to the original problem and plug 5 in for y.
All right, so let's go back. I'm going to get in the habit of trying to write higher up on the board because I feel like I keep writing in the middle and it's not a good thing. So, yeah. Oh, I heard someone already solved this. So the other equation was what? X equals y minus 4. So what do we know? So the x equals, and do we know what y is? Y is 5 minus 4. So what does x equal?
1.
I think during that whole problem, I made one comment, and that was it. Would you like to do another one?
So I think for me, it's the negatives that trip me up. When we get to when we got to the negative 10 times y, that was easy because you just put them together. So it's negative 10y. And then because it's subtraction, I'm separating that fraction and that's a positive 4, where you're saying it's a negative 4. That's where I get tripped up.
Okay, so you get tripped up on adding the negative, or you get tripped up on multiplying the variables.
Right, because inside the parentheses, it's y minus 4.
Mm-hmm.
4 is positive. It's not negative. In my brain, that's the way I'm seeing it. So
oh,
when
okay.
you solve it, you're saying negative 10y and then negative 10 times negative 4.
Yeah, so if we're looking at something like this, we can't really combine these. All we can do is just say, okay, this is going to be negative 10y. Now, because there's a subtraction sign here, we have to treat it as a negative 4. So anything before that number, treat it as whatever that is. So if it's negative, then it's a negative 4. If we're subtracting, it's a negative 4. If we're adding, it's a positive 4. Does that make sense?
Okay. okay, I get it.
Yeah, take it at face value.
They're looking at right.
Yeah.
So if we were to erase the y out of that equation, then we're left with just -4.
Exactly.
We combine the y with the -10.
Smoking it.
Now we're just left with -4. So 10 times -4. Okay.
Yeah. Should we do another one?
Stop right there and I start second guessing myself, and I'm like,
That's all right. There is a lot of philosophy with this, and again, I know that this a lot of times seems intimidating, and it's something that we haven't done in a while. But I'm telling you now, no one is the master of this. It's all about practice and coming up with what you feel comfortable with. Like, I mean, I remember when they used to have proficiencies in high school. I failed my math proficiency the first time. And I gave up like going to football practice and came into a teacher's class that taught it all throughout the summer. And I remember my friends making fun of me, and it was completely worth it. And now I would be hard pressed to find a teacher who's more comfortable with math than I am. But a lot of it just comes with taking these problems, looking at where I get tripped up, just like we're doing, called metacognition, and then coming up with my own step-by-step method and getting comfortable with it and repeating it so that I know it's going to be efficient, right? So the more that we do that, when you're like, hey, I know that I get confused here, that's why I draw the arrows to remind myself. So it's all those little things that the metacognition that will help us with this, right? So don't think anyone's mastered it. Like I said, I can't even emphasize this enough. There are teachers who spend...
I think the practice is helping us. I think the practice is helping us get faster to it. So if we could do one more, I agree.
Yeah, we have plenty of time. We got plenty of time, plenty of problems. So let's do some more. And again, as you start to notice that you're doing better with writing out the steps, or if it helps you to draw arrows or whatever, this is where we want to become very efficient with it, right? So let's always try to keep that same method. That was a horrible 5. So it'd be 5x minus 4y equals -10. Y equals 2x minus 5. Put it back on the light.
What's the first number?
5. Sorry, that was a goofy 5. 5x.
5.
Sorry.
Thank you. That's all right. Thank you.
Very welcome.
Ruth is trying to join the call, but it's given her the same problem it was given me.
Okay. I will call Ruth. Okay. Sorry, just bear with me one moment there, Ruth. I'm gonna make sure I can find your number.
What, baby?
Something that on my time I have to do my Facebook. When? Is there something kind?
Okay, I'll message her.
Hi, Mom.
What, baby?
Mama just asked me what I want for my birthday, and she's going to go get it right now.
Just because you asked for something doesn't mean we're good.
No, she said just in case I don't find it. To the mom.
Hello?
Hello, Ruth?
Yes.
All right, so I'm gonna put you through to the conference call.
We're okay. Okay, thank you.
Very welcome. All right, and Ruth is now with us.
Hi, guys. Hey, Ruth. All right, I'm ready.
Ready?
I'm not ready yet.
Okay, I'll give you a minute.
I'm ready too.
Okay, and is make sure everyone in the live chat is ready as well.
I'm still working on it.
Okay.
My God, I hope I got it right. I'm gonna be
Plug it back in.
I got this.
Yeah, plug it back into the equation, and you'll know immediately if you got it right.
I know you got it right, Hildy. Get out of here. I didn't bug you with your pictures. Leave me alone. Good job. I'm ready.
Okay. Everybody else ready as well? At home?
Yes.
Okay. So what's the first thing that we're going to do?
Who wants to take this one?
Yeah. What's the very first thing we're going to do?
We're going to rewrite the problem.
Okay. And
It's 5.
okay. What's it going to be?
5x. Sorry.
Yep. 5x.
5x minus 4. Parentheses 2x minus 5
Equals negative
equals
10.
negative 10.
Now what?
And we're going to multiply the negative 4 times 2x. We're going to get negative 8x.
This is going to be negative 8x.
For 5x minus 8x. No?
What's that?
Yeah, the 5x. What happened? So 5x minus 8x. We write that out too, no?
Yes. It's still there. I just haven't written it yet. But we just have to finish everything here.
And plus 20, because we're also multiplying the negative 4 with negative 5. That's plus 20.
Equals negative 10.
Negative 10. And then we're going to eliminate the numbers.
So now what?
So we're taking 20 away from both sides because we're eliminating the number.
Wow. All right. Well, you may not be allowed to answer anymore because You're smoking it.
I actually got it wrong, but only because of the negative positive.
And that's okay. When you plug it back in, then you know that your signs are off. So that's good. You're self-correcting.
Okay. Okay, so 5x minus 8x equals negative 30.
5x minus 8x equals negative 30. So what do I do from there?
I'm going to solve the x's.
Yeah.
5 minus 8x, negative 3x equals negative 30. This is where I messed up. When I divided by 3, instead of positive 10, I got negative 10.
Okay, but what kind of 3 are we dividing by?
Negative 3.
So x must equal
Positive 3.
negative 30 divided by 3?
Negative 3 divided.
Negative 30, remember?
3x.
Negative 30 divided by negative 3.
Yeah, so positive 10. Positive 10, yeah.
Yeah.
I got negative 10 because the negatives and positives are messing me up too. But
So one of the things I would always do, if that trips you up, plug it back into the equation. And then if you see that it's off, switch the sign. I mean, obviously, like we know the rules, its signs are the same, it's positive. If their signs are not the same, it's negative. But if that escapes you, then plug it back into the equation. Because if it's off, you might go, oh, let me see if it's a negative 10. Let me see if it's a positive 10.
okay.
Yeah.
Well, I'm three-quarter ways.
There you go.
It was almost.
There you go. All right. So what do we do now?
X equals 10.
So what's the next step?
We're gonna plug in the 10 into y equals 2 times 10, 20 minus 5, 15. So y equals 15.
Okay.
You did it.
Yeah. So let's plug that back in. Let's see.
I feel better. Like, definitely, practice is definitely healthy.
Yeah. I don't know. I heard you guys solve it, but just for the sake of everybody at home and people who haven't had a chance to speak up. So we know that x equals 10. So we're going to say y equals 2 times 10 subtracted by 5. So 2 times 10 is 20. Subtracted by 5. Y equals 15. Questions on that so far?
I was good on this one.
Okay. Would you guys like to move on to a new method or do one more with the substitution method?
We can move on.
Okay.
Yeah, we can move on.
Okay. So there's going to be another method that we can use to solve, and I sent this out as a link through the email. So there's the substitution method, and then you also have the elimination method. So we can move on straight to the practice problems if everybody got a chance to see it. If not, I can send a link, and then we can also then do the practice problems. So depends on how everybody feels.
I was taking notes. I'm sorry. Can you repeat that?
Yeah, I sent out a link with a I sent out a Khan Academy link where it talked about elimination and substitution. So I just wanted to see if everyone had a chance to look at the elimination one, can put up problems, or if we prefer to do it by if we prefer to have a whole lesson on it again or send out another link, whatever you guys prefer.
I didn't have a chance to watch it. I only watched the first video. I got halfway through the second video. And I haven't received any emails from you since the 15th.
You ever received any emails from me?
No, the last email I got from you was on April 15th.
Okay, so let me.
Have you checked your junk mail? My favorite keeps telling me I'm out of space.
Yeah, if not, I can get another email from you.
Okay, yeah, I have other ones. I'll text this. For the longest, his emails were going to my junk, and I was getting emails for him.
And I also sent it out to your phones as well.
Really?
Yeah, so I actually sent a text message out to your phones. It may cut it off, but if you get like a message and it's cut off, that's from me.
Oh, okay.
Yeah, so if you see that and you're like, it says like, oh, new link, and then the link is like cut off, that's a message from me.
I never get any text messages from you. Me either. I get like, I'll see Ildi's message and like her response to whatever you're texting, but I don't get your message. It's weird.
Oh, okay. Yeah, you know what? I do get 2 rejected numbers. So what I'll do is in the morning when I'm sending out the videos, I'm just going to send it to you, both of you guys, directly as a text message, because I convert phone numbers. I convert phone numbers to emails, and then I send it out that way so that CSN knows what we're doing. But what I'll do from now on is for Ruth and Danny, I'll just send it to you guys as a straight up text message.
Yes, please, because I've never received a message from you, a text message. And like I said, at first all my emails would go to my junk, and I just realized it was going there after a while.
Oh, okay. Yeah. I can make sure that I send it out in a couple of different ways. Would you guys like this? Would you guys like me to send you the link for Khan Academy and watch the video, or just start off with what the elimination method is? What do you guys prefer?
I would rather just start off. Yeah, I was going to say the same thing. I'm okay with that. Yes, me too.
Okay. Just a second, I just got a message. Okay, thank you for that email.
That was just me sending you my other email.
Oh, okay. All right. So let's go ahead, and there's going to be a couple of different ways we can solve this. So I'm going to put up a sample problem, and then we're going to talk about the other method that we have. And then we'll go from there. Any questions about that?
Nope. Ready to go.
Okay. So let's look at a sample problem here. So let's look at. So we know how to use the substitution method when we know what y equals. So now we're going to talk about using the elimination method. So let's say we have negative x plus, well, let me go on the other side because I feel like I keep writing it sloppy. So we have negative x plus 6y equals 8. And then we're going to have 7x minus y equals negative 2. And I'll give you guys a moment to write that down. So just remember that you can use both methods. Now, we obviously don't know what y or x equals, so we can't really use the substitution method, but we still have some options. All right, so the same thing that we're always doing is trying to eliminate the variable. It's the same thing that we're going to do now. All right, so none of these have like opposite values where we can eliminate it right off the bat. So we don't have that as an option. Does that make sense so far? So what we can do, okay, so like right off the bat, let's say if there was a negative y and a positive y, I could eliminate that. Like right off the bat, I would see that. Does that make sense? Some problems will have obvious like inverse operations in them where I can look at it and I can automatically tell that something's going to cancel out. But here, it's pretty obvious that nothing's going to cancel out. Does that make sense? I'm actually going to have to work the problem. Does that make sense so far? What's that?
Kind of.
Okay, so let's say it was negative x plus 6y equals 8. And let's say this one was x plus 8y equals negative 2. Right here, right off the bat, I could eliminate that because negative 1x plus x gives me nothing, right? So I could automatically get rid of that. Does that make sense?
Right. Yes.
But we don't have that here. So we can't like eliminate that and then solve for y. We have to actually combine these together. Does that make sense?
Yeah, we just take that 1x away from the 7x and then it just makes 6x?
Correct. So we're just going to treat it as a regular problem and combine like terms. So we're going to add them together, right? So you're exactly right. Negative x and 7y, that's going to give us what? Or negative x and positive 7x. What's that going to give us?
6x.
All right, so then 6x plus, or is it a plus? I don't even know.
No. We're also going to do the same thing, y and 6y. So we're going to subtract the y from the 6y.
Yeah, which is going to give us what?
Negative 5y.
Well, so if we look up here,
Sorry, negative 7y.
well,
Negative 7y.
positive 6 minus 1.
5y. Minus 1 is 5.
5y, right? So we're going to add 5y. Makes sense? We're adding all of this together. What else?
8 plus negative 2.
8 plus negative 2? Remember, we're adding all of this together.
6.
Good. Does this make sense so far?
8 plus negative 2. Is it negative? Is it 6? Oh, I can't.
Yeah, because 8 minus 2 is 6. It's a negative 2. Think of it this way. You have $8 in the bank. You just took out 2. Or you're negative $2 in the bank. You just added 8.
Okay. Yeah.
Okay. So make sense so far?
I'm sure on the second problem will all be better.
There we go. Okay. So
it's just a regular subtraction and addition.
So far, yes.
Put them underneath each other anyway.
Correct.
Okay.
No. I was agreeing with you. Yes.
Okay.
So here we ended up getting 6. Right? So we combined them and we ended up getting 6. So we're going to take that and we're going to look at the bottom equation, which is 7x minus y equals -2. Because we combined them, we got 6. So we're going to take that 6 and we're going to multiply it into this bottom equation. We're trying to eliminate the equation. So when we combine them, it gives us a number that we can use to start to eliminate. So we're going to take this bottom equation and we're going to multiply it by 6 because that's what we got as our number to help us eliminate. Does that make sense so far?
No.
Okay, so
what are we? I don't understand why we're going back to the.
Yes, because remember, we're trying to eliminate. We don't know what y equals. So our goal is always to eliminate everything to figure out what each value is, right? So here, 7x minus y equals -2. What we're going to do is we're going to multiply it by 6 because that's when we combined them. We knew that it gave us 6. So this number will work for both equations.
So we're doing 7x times 6 and then y times 6?
Correct.
Okay.
Does that make sense so far?
So 7 times 6 is 42. So it'll be 42x?
Correct.
Minus 6?
42x. And then remember, we're taking that 6 and we're multiplying it in there. So, yeah. So what would it be?
But are we keeping the negative? So is it negative y times 6 or is it just y times 6?
It's negative y times 6.
So it'll be -6.
Correct. And what else?
-6y.
-6y. And one more thing.
We multiplied equals 2, -2.
6 times -2. Because remember, we're going to take this and we're going to multiply it into all of these. We're just trying to eliminate one of these equations.
So it's -12.
Correct. There's multiple ways to do this. So we're going to stick with this for a while. So kind of like bear with us if this method isn't as easy as the substitution method. All we did was combine them. We know that 6 will go into both equations. And we decided to take 6 and multiply it into our bottom equation.
6 times 7, 6 times 6. Okay. All right. So now do we need to do the same thing to the top equation?
Before we move on to that, I just want to make sure this makes sense.
As much as it's going to for right now. Right about the 42 or 6y. We won't know if it'll make sense until we're into the third problem.
Okay. But so far, so good. We understand how we got here, right?
Yeah, we're following along.
Okay. And then somebody else had mentioned, well, if we did that to one problem, what are we going to do with the other one?
The same thing, no?
Yeah. And also, what do you notice about this problem now and the original equation?
I noticed that it changed.
It changed, and now these two cancel out. So what did I do with that y?
Oh shit! I see it now.
Yeah.
So 42x minus,
Yeah. Let me erase everything in the middle. Let me erase everything in the middle so that it's a little clearer. So now that I found the common number, remember how we we're talking about canceling the numbers out. So now we have 42x minus 6y equals negative 12.
Yeah, we can't take 6y out of x because one is y, one is x. We can't do that, can we?
Well,
42.
right now, after combining them and finding out that I can multiply it by 6, notice how I made it so the y cancels out.
So now we're just not going to do anything with the y. We're just going to be 42x equals negative 12.
Yeah, now
we need to deal with the 8 and the 12.
Yeah, now we need to combine everything. All right, does that make sense?
Yeah. Let's combine it and let's see if it makes sense.
Okay, so remember, so since we are trying to eliminate everything, then we would end up subtracting, right? We're trying to get rid of everything. So now, so we added it all together so we can get these signs to be the same. We added them all together. Now we're going to subtract them all together. So all of this now needs to be subtracted, right? So negative 1 subtracted by, so right here, negative 1x subtracted by 42x. Keep, change. That's going to give me negative 43x. 6y plus negative 6y, or 6y subtracted by negative 6y, right? So this would be 6y subtracted by negative 6y. Keep, change. So that would give me positive 12. We keep doing the opposite so we can start eliminating things. Does that make sense so far? We're still doing the inverse operations. We added them both together so we can get the same sign, right? Now that we have the same sign, we're subtracting them. We're still working to eliminate everything.
I'm going to need a big piece of paper for this test.
Yes. But remember, this is only one method. There's multiple methods.
So let's move on to the simpler one.
We have to know how to do all of them, but some of them are going to be more efficient and easier to use than others. Does this make sense so far? How we have 43x plus 12y equals, so what's 8 minus negative 12?
I just had that. Where did it go? Negative 4.
8 minus negative 12?
8 minus 12.
Negative 12.
Negative 20 minus 12. Yeah.
Not negative 20. Okay, so look at it this way. 8 minus negative 12. Keep, change.
Positive 4? Negative 4.
Remember, so we keep this the same. Change and change, right? Keep, change. Keep, change.
Negative 4. I had $8 and had to pay 12. I'm in negative 4.
So that works when we're adding, right? But when we're subtracting integers, use keep, change. Keep your first number, keep your first add in the same, change the sign to addition, and change whatever sign we're subtracting by. Keep,
I don't
change.
see the right side of the board. It's out of the picture.
Oh, okay. Is it easy to see now?
Now it's in there. Yeah, thank you.
Very welcome. Does that make sense? The keep, change.
I don't know. So 8 minus 12.
So what would it be?
Positive 20.
There we go. Does that make sense so far?
I don't think any of it makes sense to me.
Where did I first lose you?
The whole thing. The whole thing just seems very difficult and a lot of steps. Yeah, I'm over here rewriting because I was trying to work on my own, but I wasn't doing very well.
That's all right. Like I said, this is one method. There's going to be several methods, but just let me know on this where we got lost.
I just always get lost with the negative and positive signs.
The integers? Okay. So when we're adding, think of it as money. We're just adding positive and negative numbers. When we're subtracting, do keep change. KCC, change. And don't worry, we're gonna have plenty of time with this. I just want to know like where anyone feels confused.
Looking at all these problems now we started out with 2 and now I have 1, 2, 3, 4,
Yeah,
5 different problems.
Yeah, the elimination method is going to be trickier than the substitution method.
I think we just need to keep going and see if you work it out, and then with the second problem, we can probably work along better.
Okay. So does everybody understand where we are so far right now?
The best that we can be, yes.
Okay. So if you look at the top equation, it's negative x plus 6y equals 8. So if we multiply that by 7, then we would have negative 7x plus 42 equals 56. All right. Does that make sense so far?
No.
Okay. So remember, our whole goal is our whole goal is to eliminate, right? So we want to eliminate and get the y by itself. So
where did 56 come from?
We were multiplying by the 7 because our goal is to eventually get this on its own, because in the original equation, it was 7x minus y equals negative 2.
Okay. So now what are we doing with that problem?
So we're still trying to get the y by itself. So now what we would have to do is start to isolate the y. Okay? Does that make sense so far?
I get where we're going. I'm just trying to figure out which problems we're now working with and which numbers. So now we dealt with that top equation, the negative x, so now we're dealing with the second equation, the 7x minus y?
Correct.
Okay.
Because our whole goal was to eliminate the x.
And we're still working with the negative 43x plus 12y.
Well, yeah, now we have negative 43x plus 12y. So we converted that, right? Now,
okay,
when we work it out, you're going to see that we're going to end up getting the y by itself.
Okay. Show us, teacher.
Okay. So does that so far everything I have up, does that make sense?
I'm just gonna watch and see if it clicks. Yeah, I think we're along right now. I think with the second problem, we'll have a better grasp of where we're headed. Right now, this is just like a suspense movie. We don't know what's going to happen next.
Okay. All right. So
I'm on the edge of my seat.
okay. So let's then look at rewriting. So let's look at then at the equation that we're trying to get rid of. We're trying to get rid of the x. So the original equation, right? Now we've worked this out. We know that 6 and 7 will work for both sides. So now the goal is to eliminate the x. So let's look at the original equation, 7x minus y equals -2, because I now know what numbers to use to eliminate one of the variables. And in this case, I'm trying to eliminate the x.
Okay.
Right. So I have -7x minus y equals -2. Everybody, and I know we're all kind of confused. Okay, so I originally had the 7. I originally had 7x plus 42 equals 56. And I had that when I started multiplying by 7, right? When I multiplied this whole thing by 7. I'm going to finish this one up, then I'm going to go back and look at another method. Okay, so when I multiplied all of that into there, y equals, and that would be again the 56. So I got here. Remember how I got my 6 and my 7 when I added them together and then subtracted them together? I did that so I could, again, eliminate one of these. Now I'm in a position where I have eliminated one of them. So I can actually now get the y by itself.
So it's just going to be positive 42y.
So yeah, I get rid of my 7x. -1y plus 42y gives me 41y. And then that equals 54. And I know we're down to the last 8 minutes. Okay. So I'm going to send out some resources on a couple of different elimination methods, because we can use the origin to eliminate this. We can also use these inverse operations with coefficients. There's a lot of methods. And we've been doing almost 2.5 hours of math straight. And we have about 8 minutes left. So I'm going to send out some resources to help you. And then tomorrow, we're going to start with this again, because we're going to talk about figurative language for reading. That shouldn't take too long. So we're going to hit this again tomorrow in the morning, because we're about 8 minutes shy from finishing up the class. So I'm going to send out some links now. Make sure that you look at them. Let me see if anybody else had a question on the live stream. Okay. No. All right.
Are we going to finish this one?
Well, we got about 7 minutes, and I don't want to end up going over 30, especially when we've been doing it for like 2.5 hours. And I also like to preload everything before we do it, because my goal would be for us to hit 2 math standards a day. And I don't want to.
Like Netflix, when the season ends and you got to wait for next season to come out.
Oh no, this is one method. There's still more methods for variables. So I mean, if you guys want to go till 2 o'clock, we could go till 2 o'clock.
Don't
Because we
thank
could use
you.
the origin.
My brain is
We could use
going
some.
right
We
now.
could.
But I'm lost. Are we done with this problem? That's it?
We're gonna stop here.
41Y?
Yeah. Because if I'm going through it and everyone's like, let's wait for the next problem, we're gonna go on till like 12:30. And that's already after doing 2.5 hours with using the substitution method. So I don't want to burn anybody out or have the class go on till 12:30. I'm down if you guys want to go. I will keep going and I will teach until the cows come home. But if I'm going through the steps and no one's really following along with me and we have 6 minutes left of class, I'd rather pick it up again tomorrow. That's me.
I agree. Yeah, because I am confused.
Yeah. And we have 6 minutes left and we've been doing math for 2.5 hours.
Yeah, tomorrow let's start fresh and then we can.
What's that?
I'm confused, but I feel like it will make sense if I know how the story ends.
There's going to be a lot more to this because see now we're going to be solving for y. We still need to solve for x, and that's one of the elimination strategies. But there's going to be other elimination strategies.
All we've done is made a bunch of bigger numbers.
Yes, because we're trying to. The whole goal was to get the 7x to isolate itself. We were trying to eliminate it. So we had to figure out what I could multiply both equations by to eliminate the x. And then we have to figure out what we can multiply by to eliminate the y. So the whole goal is to eliminate the variables and then work out the equation.
All right.
Hey, if you want to stay, we can stay. We can stay.
I don't like cliffhangers. I need to know.
Then let's stay.
how it ends.
If you want to stay, we will stay. I will teach. I'm a crazy teacher. I'll teach till 5 o'clock at night. I taught at CSN for 2 years till 10 o'clock at night after teaching in the morning from 7 to 3. But I want to respect everybody's time because I know that going on till 12:30, 1 o'clock is probably not what the majority want to do. But
I will probably catch up tomorrow morning because I can't take in anymore right now because I feel like
it is 2.5 hours of math. It was like almost 3 full hours of math, 2.5 hours at least.
oh, I'm good for tomorrow. But if Danny wants to know the end of it, then you guys can go on. I
Learned earlier today with the substitution method. This is the elimination method. And then we're going to also be able to use the origin to also figure out. So if you plug in 0, 0. So there's going to be a couple of different strategies that we're going to have. That's why I wanted to pick it up tomorrow so that at length we could talk about finishing up with the elimination method and then also introducing using the origin. And I can also send out additional resources so that tomorrow when we start, everybody's on the same page.
Yeah, that's fine.
Sure?
I'll figure it out. Yeah, no, it's cool. I have my resources. I'm gonna figure it out.
Yeah. So if you're looking at using Aztec or Khan Academy, we're talking about eliminating systems of equations or solving systems of equations using elimination. And there's a couple of elimination strategies. And I'm going to send out some links. Actually, I can send those out right now.
Alrighty.
And then we're going to pick up on that tomorrow. I think that we'll probably use the first hour and a half just to finish up the elimination methods. And then we're going to move on to figurative language.
Sounds good.
Yeah.
Okay.
So I'm going to send it out in the live chat.
Danny.
I'm going to send it out in the live chat. And then if you don't get it, let me know. And I can also email it as well. One second. Why is this? So we're going to look at elimination strategies. Sorry if you hear the maintenance people in the background. So that's going to be a good resource. That's going to be a video with questions on different elimination strategies. It's going to give you some sample problems. So look at that. And then tomorrow we're going to pick up with elimination, and then we'll look at using the origin. Thursday, we should have the Amy come in, and she's going to talk to us about some resources for the CSN offers and what class will look like for next term. Any burning questions before we call it a day? 12 o'clock on the dot.
No, I'm good. Thank you.
All right. See you guys tomorrow.
Okay, bye.
Bye.
Bye, ladies. Bye.
Bye.
You are currently the only person in this conference.
Hello?